Periodic functions now are a little different. They follow a pattern. They are going to start at some value, go through some period of oscillation, and return to their initial value. These show up all over the place. One example is the sine wave, sine of x. This is one period of it. It goes up, climbs up at a maximum value of pi over 2 at 1, where it's equal to 1, and it drops back down to, at 0 when it's equal to pi, and it keeps going down until it reaches -1 at 3 pi over 2, and then it grows up until 0 at 2 pi, and then it'll repeat itself. But what exactly is sine of x? In trigonometry, right triangles are mostly studied. A right triangle is any triangle that has a 90-degree angle. Let's call this angle x. We'll call this the right triangle. The hypotenuse is always the largest leg. This would be the adjacent side, and this would be the opposite leg. There are three main trig functions: sine of x, cosine, and tangent. Sine of x would be the opposite over the hypotenuse. Cosine of x would be the adjacent over the hypotenuse. And tangent of x is equal to sine over cosine, which is opposite over adjacent, and has its own pattern, but I'll mostly be focusing on sine and cosine. There's the Pythagorean theorem also, which says that the sum of the squares of a triangle, so let's say a squared, b squared is equal to c squared. What does that mean? That means that the adjacent side, adjacent squared plus the opposite squared, is equal to the hypotenuse squared. And this is an important relation when it comes to finding values and stuff. If we imagine that the adjacent and the opposite side lengths are equal, that means that their angles are also going to be equal. So that would be that a squared plus a squared is equal to c squared. If we set c is equal to 1, then we have 2a squared is equal to 1, or a squared is equal to 1 over 2, where now a is equal to 1 over the square root of 2. Typically, when it comes to lengths of something, it can only be a positive value. You can't have a negative length. But when it comes to trigonometry, later on, when it comes to like the unit circle, you can have a negative value for this because it goes in a negative x direction. Also, for some reason, mathematicians don't like to have square roots in the denominator, so they'll radicalize it, which is just taking away the square root. And to do that, you just multiply by 1. This term is just 1, and that leaves us with root 2 over root 2, which is just root 2 over 2. And that's the length of our A length. We can say A, C, or rather A, B, C, but we said that B is equal to A, so we'll just say it like that. Now, to find the sine of this, like the sine of x, we know that the opposite and the adjacent are both equal to root 2 over 2, and the hypotenuse is equal to 1. So we have our opposite, which is root 2 over 2, and our hypotenuse is 1, which just leaves us with root 2 over 2. Oops, no radical right there. That's our sine value. Cosine would be the same. It would, because our adjacent is also root 2 over 2. Finding the tangent then would just be dividing those two, and because they're both equal, it would just be 1. Sine and cosine are ratios, as defined here. So if we change, clean it up a little bit, if we change the leg length, if we change the angle a little bit, the leg length is going to change. Like if we make this angle bigger, the opposite leg is going to grow, and the adjacent leg would shrink a little bit. That is just how it works. So the sine of the angle changes based on what the angle is, of course. I mean, that's typically how functions work. I'll explain a little bit more in the next video. Thank you for watching.